Welcome to Ask and Learn.
Okay, the question's asking us to draw the graph of a function defined on 0, 8 such that f of 0 is equal to f of 8 is equal to 3. And the function does not satisfy the conclusion of Rolle's theorem on Rolle's theorems on the closed interval from 0 to 8. So here they're asking us to draw a function that does not satisfy the conclusions of Rolle's theorem. So if you recall, the conditions for Rolle's theorem are continuity on the closed interval, so from 0 to 8, and the second condition is differentiability, so it has to be differentiable, so you can take the derivative at any point on the open interval, which means it does not include the endpoint. And the third condition is the endpoints of the two function equal each other. So the beginning point and the endpoint equal each other. So in this case, it would be f of 0 and f of 8. Those two will equal each other. So the question is asking us to draw such a function where this condition is true, but does not satisfy. So one of these will not be right. So a very common example is this function. It's a, oh, that is a horrible derivative. Let's do that again. Okay. This is a straight line. But so essentially, this function is continuous on this interval. I can draw this function without picking up my pencil or my mouse in this case. So this is true. And we know that the endpoints, f of 0, which is 3, and f of 8, which is also 3, is true. So this is also a true statement. But this condition right here, differentiable on 0, 8, this isn't true because at this point, whatever point this may be, let's just call it x. This point at x on some number between 0 and 8, I can't take the derivative here because this is a sharp point. And you're not allowed to take a derivative at a sharp point because there are infinitely many possible derivatives. Because if you look closely at a sharp point, as I've drawn here, you can have a derivative like this, you can have a tangent like that, you can have a tangent like that, have a tangent like that, and it's just inconclusive. So this statement right here is not true. So this is a graph of a function that does not satisfy the conclusion of Rolle's theorem. And if we take it further, if we remember the conclusion of Rolle's theorem, it says that there will be a c in this interval such that the derivative is equal to 0. And you can see in this function there's no point where there's a derivative where if we take the tangent line at any point in this function, it would be equal to 0, because here you just have a slope, you have a slope here, and then at this point, as I said here, this is not a place where you can differentiate. So this is a graph that does not satisfy the conclusion of Rolle's theorem.